Assalamu alaikum warahmatullahi wabarakatuh. This is an introduction before taking the lab experiments. So in any electrical system, we have two types of signal, either AC or DC. The DC signal will experience a constant value over time. That means at any given time, the value will be 5 volt, and it will experience only one direction. So that means in this circuit, the flow of current will be always like this at any given time, while the DC circuit will have two directions, positive and negative, and the value is changing with time. So at 2.5 I may get 5 volt, but at the initial time I will get 0 volt. After like 1 second I may get 2 volt, and here the negative part. So in this positive part, first one, the direction will be clockwise, while the value is changing until the maximum, then 0. Starts from 0 to the maximum, then 0. Then the opposite direction, the current will change its direction to the other side. So we will have a variable value over time and both direction. So now let's move to the loads. The first load is resistive load with the symbol R and unit ohm, and this is the drawing symbol. The R, or the resistive load, the effect of the current and voltage on the resistive load will be like this. So there is no phase shift between the voltage and current. I mean, in this circuit, the voltage will be across the resistor and the current will be passing at the same time, as you can see here. There is no phase shift. So at zero there is no voltage, no current. At here the voltage will be maximum and the current will be maximum, and at this point the voltage and the current will be 0. So there is no phase shift, same behavior between the current and voltage. That's why the angle is 0. The second type is inductive load. The symbol is L and the unit is Henry, and this is the drawing symbol. In the inductive load, there is a phase shift between the voltage and the current. That means initially, at the initial time, when time is 0, there is no voltage, no current. Then after some time, the voltage will appear here, but the current still. At 90 degree, the current will start appearing while the voltage at the maximum. So this phase shift has an angle which is 90 degree. In order to take the reactance of the inductive, or switch the inductive value in Henry to ohm, we use the reactance. The reactance has an equation 2 by FL. So the value of the L in Henry will be here, and this is the frequency. So in order to get XL, we have to multiply 2 by, multiply the frequency of the source, 60 or 50 Hz, multiply the inductor value. This one, like for example, this one 2.5 millihenry. So it will be here 2.5 multiply 10 to the power minus 3, because milli. The unit of the inductive reactance is ohm. So we can compare this one with the resistive because it's ohm. The third type is the capacitive load. The symbol is C, the unit is farad, and this is the drawing symbol. In any capacitive load, there is a phase shift between the voltage and the current, which is minus 90 degree. So the voltage will be leading the current at this type of load. That means the current will start its signal first, then the voltage appear at 90 degree. So it's opposite to the inductive load. The reactance or the capacitive reactance, which give me an ohmic unit, will be taken from this equation, 1 over 2 pi Fc. The F is the frequency of the supply, and the C is the capacitance value in farad or microfarad. Microfarad is just 10 to the power minus 6. So let's take this example. If we want to add R, XL, XC, and notice that I didn't say RLC because the unit of L is Henry and the unit of C is Farad. So I have to make a common unit between them, which is the ohmic value here, R ohm, XL ohm, XC ohm. So if R is 50 ohm, XL is 40 ohm, and XC is 30 ohm, and we want to add them together, R plus R, just algebraic sum. So 50 plus 50. This example, just example. If I want to add the R twice, and we know that in any resistive load there is no phase shift. That means 50 plus 50 is 100. As a vectors, this is 50, this is 50. The total is 100 because they are in the same direction. If this is like if we have R1, R2, and this is like 40, and this is minus 30, it will be like this: 40, 30, the sum will be 10. Now, if I want to add resistive and inductive load, I know that there is no phase shift in the resistive, and the inductive reactance XL I have 90 degree, so this is the resistive value 50, no angle, and this is 40. So this is a right triangle. How can I find the hypotenuse or this one الوتر؟ أجيبها من فيثاغورس لو، قانون فيثاغورس، اللي هو ايش يقول؟ C square equal A square plus C square, A square plus B square. So عندي C equal root A square plus B square. So I can find the hypotenuse by this equation. So to find the impedance or the total الامبيدينس، هذا مصطلح يجمع الريزيستنس والرياكتنس. يعني if you have just R, if you have just resistance, you can say it R. If you have reactance, either XL or XC, you can call them inductive or capacitive reactance. But if you have to add reactance and resistance, we have a term which is impedance. So impedance will have both resistance and reactance. So the impedance here will be 50 square plus 40 square, and we will get 46.03. So I cannot say it's 90. I cannot add them together. No, we have to use this this equation. Now, how can I find the angle here? Okay, since this one is 90 degree and this is 0 degree, when I add them I got the impedance. So how can I know the angle of the impedance? The angle will be by using this equation. So tan theta equal A, the opposite, over B, the adjacent. So the angle will be tan inverse A over B. So tan inverse 40 over 50, we will get 38.6. So the Z or the impedance will be 64.3, the value, with angle of 38.6. Now if I have R and capacitive load, we'll do the same, 50. Since the XC is minus 90, we'll go down, and we will by doing the Pythagoras law we will get 58.3, and the angle is 30.1, the angle here. Now if I have inductive and capacitive load, I know that the inductive is 90 and the capacitive is minus 90. I have no R, that means I will be on the vertical axis, so 40 and 30 down, المجموع 10 up. Since it's up, that means XL, because up is positive, which is XL, positive angle. So the reactance will be XL, because the value of XL is more than XC. This is 40, this is 30. So the total will be XL, XC will be cancelled. Or we can make them as Z. Why? Because the impedance equal R, which is 0 plus 10 مجموع 10. So هذا XL وهذا R، الR 0 تكنسل، فمعناها Z equal 10. And the angle is 90 because it's the angle of the inductive load. Now if I have a resistive or inductive capacitive load, so what I have to do first is find the difference between XL and XC. So XL is 40, XC is 30, the difference is 10 ohm. Now I can do Pythagoras. So R is 50, X or reactance is 10, since it's inductive, so that's mean 90 degree. So the vector diagram will be 50 and 10 going up because it's inductive, and this is the hypotenuse أو الوتر. نستخدم القانون اللي هو 50 سكوير بلس 10 سكوير، وهذا الناتج. الأنجل تتطلع بالقانون هذا. So أول شيء لازم أجيب الفرق بين الاندكتيف والكاباسيتيف لود، بعدين أستخدم فيثاغورس.